All right, good morning, class, and we're going to go through 2.6, which is coordinates and line graphs today. We always start, as we've talked before, with our key vocabulary. So we are going to talk about ordered pairs first. I do believe Mrs. Pettis covered this in 3rd grade, so most of you should remember a little bit about an ordered pair. And these are basically, I like to share that they are the over and up of a set of 2 numbers on a coordinate, and I'm abbreviating, grid. So I'm going to show you an example, and a lot of you will go, oh, I remember. But I always have my finger do a little dance where you go over, up, over, join me, over, up, over, up. Nobody can remember when they see the ordered pair, which, do you go up first or do you go over first? And I'm like, remember our dance. Remember our dance. That's what we do. So on a coordinate plane, which is like kind of like an X or a T, we're going to just work today with the over and up. We're not going to deal with negative numbers. But let's talk about the ordered pair of 2, 3. What I used to do with students who had trouble remembering is before you even start, make sure that you draw the arrows underneath them so you know which way they go. So you go 2 over, so if this is my 0 in the middle, I'm going to go 1, 2 over, and then 1, 2, 3 up, so it would end up being right there. 2 over. I went this far over, I went this far up, so my point ends up right there on the grid. These 2 numbers are called coordinates. And a lot of you might recognize that vocabulary word from things like longitude and latitude. Give me your coordinates. If you give the longitude and latitude, it's kind of like the Earth is a big coordinate plane. So we also need to talk about the origin. And that's a vocabulary word, and that is where it starts. The origin, I'm going to draw a little arrow to. The origin is wherever 0, 0 is. And usually it's right in that smack dab in the middle. So when you hear the word origin, when you're talking about a coordinate plane, they're talking about that place where the 2 meet, and it's usually 0, 0. The other thing that I want you to realize, I'm going to blow this up a little bit bigger. These are supposed to be like lines that go up and down. And then, of course, there's those little marks so you can see the points and where to put them. I do have some graph paper if you need on the front card. However, when you are hearing about the vertical axis, vertical is always up and down. You grow vertically, hopefully. So vertical axis. And what I'm trying not to do at my age is grow horizontally. So you go on the horizontal axis first. Oh, I wrote the word LY, horizontal axis. So the word axis, it's just that line that it lies on. So we have a vertical axis and a horizontal axis. Again, these are big giant words for what you're already familiar with right in front of you. we will talk a little bit, we will talk a little bit more about X's and Y's, but I will say that if you know a little bit about this, when you have an ordered pair, the first one is your X and your second one is your Y. So when you get an X and Y, and when you're into higher levels of algebra, you will be using your X point and your Y point and putting them on the graph. So would you please make a graph right now that shows the coordinate? Well, let's go with the coordinate pair, ordered pair of 4, 3. And I'm going to use this one that I did right here where I labeled the parts. Again, this is 0, 0 in the middle. Would you please draw that on in your notes and put that point down? Don't forget our dance. So right here should be 4, 3. If you did it right. Thumbs up if you got that one. Fantastic. So the second thing I want to talk to you about is the reason we are only talking about this part of the grid is we are going to be talking about line graphs today. So that's our next vocab, line graph. And it uses all of the principles that we see here. And this represents data, and I'm going to put reps data. I'm going to abbreviate using points. And these points are key because that's what we were just talking about right over there, those coordinates that we have. So you're going to get coordinates, and I'm going to write the word coordinates above. Connected by line segments. So let's say we have a graph that looks like this, and let's use our example of movie tickets over time. So let's do like 1970, 1980, 1990, 2000, and then 2010. Okay, and let's start over here. This is 0, and then we are going to go up by 5, 10, 15, 20. And let's take, I'm going to give you some data that would represent movie tickets in a specific place. Usually things in like New York City are way more expensive. Usually line graphs represent change over time. So if you are owning a business, you want to see how much you made on your invention in all these years. It could be 2001, 2, 3, 4, 5, and you have little lines. It reminds me of the stock market going up and down, sometimes on a daily basis. But let's pretend that we have some data. And in 1970, you could go to a movie in New York for $5. And then let's say in 1980, it went up $2.50, and so it's about $7.50. In 1990, it made a bigger jump, and it was $12.50. And it stayed that in the year 2000, but then it went up to $18 in 2010. So it's like taking the ordered pair and putting it on a grid, only now you have, and this I should label dollars for a movie ticket. in NYC, New York City. What I would need to do to make it a real line graph is, if I had a ruler, that would be even better, is take this and make these line segments. You give me a quick thumbs up if you've ever seen a graph like this in a book or on your Scholastic News. These are all over our world. This is something that you will have to probably produce when you do any sort of science. This is something that you'll have to do if you go into business. Even your personal finances, you can see how much you spend year to year on different items, and you can make choices based on these graphs. Sometimes you can even convince your parents of things using well thought out graphs. Now, the one sticky point that my last classes have had trouble with is what I call a broken scale. And so when we do that, we're going to draw a little lightning bolt at the bottom. It usually goes out and then in. Sorry. And then it goes up. It's like a little lightning bolt at the bottom. So I'm going to start it on a different sheet because again, my art, there's something to be desired in my art. But what we'll do, and then we'll go up, in, over, up. So do you see how there's like this little lightning bolt right down at the bottom? So if this is 0, what we might want to do is find the tab that we were just in. Now everybody knows my library time on my video. Sometimes we don't want to go up. The data starts at like the number 12,000. And then it's going to go up to 14,000. And then it's going to go up to 16,000. And then it's going to go up to 18,000. And then these are going to represent years. Like this right here could be 1920, 1930, 1940. What I want to point out about the broken scale, well, first of all, let me take a volunteer. Can you see what the broken scale is and why it might be useful in a line graph? So here's the broken scale. You can see the scale up the side, and this represents population, and I'm just going to write population, pop for population. And this is the title is Population in Austin, Texas, over time. Why would you have a broken scale? What does it look like to you? Start with Jane, and then Nathan, be ready to add.
Maybe since it has that one, maybe that's where the line starts, and then like it keeps going up.
So it starts at 12,000. That is a great thing to notice. Nathan.
I think kind of like Dave, that it starts at the tip of the grade file. That kind of like it shows exactly where the line starts instead of at 0. It's already.
So the rest of the graph, if I were to measure this, I'm just going to take the end of somebody's stick. This is one line on my lined paper. Does this really represent the same space as it should for 12,000?
No.
It's a shortened space. So what they have done is they have squished the graph down, because if they were to extend this graph all the way up, there would be a bunch of blank space at the bottom, and then your data would start going at the top. Let me put the points on the plane. So let's say that it started out at